Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and we continue to explain Pure Mathematics 1 all the way to Pure Mathematics 4, and today we are looking at topic number 6 and example 18, specifically differentiating arcsin x, arccos x, and arctan x. And in the same, we are told that you can use the rule dy dx, which is equals to 1 over dx dy to differentiate arcsin, arccos, and arctan x. And in example 18, we need to just employ or apply this law. But what are we being told in example 18? We are told to show that the derivative of arcsin x is 1 over the root of 1 minus x squared. That is what we are to show. And what do we know about it? Fine, as we talk about, let's first of all, let y be equals to arc sin x, so that we can see what we are dealing with. And I want to go a little bit behind and talk about arcsin. The arcsin function of x is the inverse sine function of x. The inverse of any function is the function that undoes what the original function had done. And in most cases, the inverse of a function returns you back to the very original starting point. So even as, let me just put it here, the arcsin of x is the inverse sine function, of x. Of course, it has to operate when x is all the way from -1 to +1. Reason being, if you plot the graph of y is equal to sine x, the minimum value of that graph is -1 and the maximum is +1. So the arcsin, being the inverse, will obviously use these kind of limits. And you know what? The inverse function, as we have just said, is the function that takes us back to the very original starting point. And we have made this kind of expression. The function followed by the inverse function of x is actually x. What do we mean? Let me just explain this in a more clear language. When we have a function of x, and let's say we are starting from a point 2, and the function of x is 2 steps to the right, that is the function of x, then the inverse function of x is 2 steps to the left. So if this was our starting point, the function of x demands that we go 2 steps to the right, 1, 2, and the inverse function demands that we go back from this particular point 2 steps to the left, 1 and 2. It means taking us back to where we began. So that means, therefore, we must talk about if y is equals to arcsin x, we may also rewrite it and have arcsin x is equals to y. If we want to introduce the sign now in this, and we have talked about that if you want to get x, we must introduce the inverse, which is already now the arc sign. That means if we have to rewrite it this way, if we introduce now the sign in this one, we're going to have the sign of arc sine of x is equals to the sine of y, because introducing the sign in both sides. Sine followed by the arc sine, a function followed by the inverse function of whatever variable is going to give us that variable. So x is equals to the sine of y. At that particular point, it means therefore, from now here, we have an expression that is starting with x. And this starting with x, we can only talk about dx dy, which is easily the cosine of the dx dy, which is the cosine of y. And from this one, if you want to rewrite it in dy dx, let's talk about it here. Dy dx is equals to 1 over, and the reciprocal on both sides, the cosine of y. But look, we are expected to give our answer in terms of 1 over the root of 1 minus x squared. So at that particular point, we don't exactly, we have no relationship between the cosine y and x. And what we need to do is look for a relationship, a trigonometric relationship that will give us x, that will relate the cosine y and x. And what do we know? We need to make the cosine y the subject of the formula here. And of course, we have this. X is equals to sine y. But we know a very, very fundamental trigonometric relationship which says from the cosine squared of y plus the sine squared of y is equals to 1. We can make the cosine y the subject of the formula, which is 1 minus the sine squared of y and the square root of that. But if you look at but x is equals to sine y, if you look at this. So this gives us the cosine of y to be equals to the square root of 1 minus x squared. And therefore, we can easily say dy dx is equals to 1 over then the root of 1 minus x squared. And this is just what we had to show. This is just what we had to show. And we can easily say, hence shown. But look, we have been able to use this particular relationship and have elaborated the function of x as opposed to its inverse. And we have also this one has come in handy in assisting us getting the final statement. Yes, that is exactly what we were to show. And moving forward, that example is over there. But of course, I would want to speak in the same video and say the following. You can use similar techniques to differentiate arc cos and arc tan, giving you the following results. And let's just register all of them here. So if y is equals to arc sine x, then dy dx is equals to what we've just realized, 1 over the root of 1 minus x squared. And if y is equals to, in the same kind of argument, if you use the same kind of argument, it will land you to arc cos x, then dy dx is equals to negative 1 over the root of 1 minus x squared. Again, if y is equals to arc tan x, then dy dx is equals to 1 over 1 plus x squared. That is, if you follow the steps we did when we were talking about y is equals to arc sine x, and we got that one. If you follow all these steps, then you will find that, and you will also find that. At the end of the day, you will have differentiated the arc sine, arc cos, and arc tan. Okay, that's the end of the video, and of course, visit my YouTube channel again, Pearson and Excel International Math by Mr. Kamoto, and of course, share widely and subscribe fast, and then like. All right.